All right, now we're going to talk about ellipses. Each one of these, separated into 4 sections, are find an equation of an ellipse. So the first one, we're supposed to find an equation of an ellipse that looks like this. The graph of it looks like this. You can tell that the vertex is at the origin. So it's going to be x squared over something plus y squared over something equal to 1. Since it's long going up and down, you can tell the distance between the vertex and the endpoint of the major axis, or the vertex, is 1, 2, 3. So I know A is 3, and B apparently is just 1, because the distance between the vertex and the endpoint of the minor axis is just 1. Since it's longer going up and down, A squared is going to go under Y, so we'll put 9 here, and we'll put a 1 here. Now officially, they don't usually write x squared over 1. They would just write it as x squared plus y squared over 9 equal to 1. They wouldn't put a 1 right there because you don't usually put a fraction with the denominator of 1. All right, let's look at our second one here. Likewise, the vertex is at the origin. So it's just going to be x squared over something plus y squared over something equal to 1. And you can tell the distance between the center and the vertex is 1, 2, 3, 4. So A is 4. And the distance between the vertex and the endpoint of the minor axis is 2. So B is 2. This is horizontal, long going across. So the biggest number gets to go into the x. So this is going to be A squared, which is 16. And this would be 4 right here. All right. Next one says, find an equation for an ellipse that has a center at the origin, a focus at 6, 0. So I'm going to kind of sketch a little picture of this. It says it has a focus at 6, 0. So let's call this 6, 0 right here. A center at the origin. If it has a focus at 6, 0 and a center, then it also has another focus over here at negative 6, 0. That has to also be true. And if it has a vertex at 8, 0, that would be out here. This would be, let's say this is 8, this is 6. It's also going to have a vertex over here at 8. So a vertex here and a vertex here. As far as the letters go, the distance between the center and the vertex is A. So I know A is 8. The distance between the center and the focus is C. So C is 6. In an ellipse, the relationship between A, B, and C is B squared is equal to A squared minus C squared, or I like to think of it as ellipse got back and cannot lie. Anyway, so B squared is equal to A squared, which is 64, minus C squared, which is 36. So 64 minus 36, 14 minus 6 is 8, 5 minus 3 is 2, so B squared is 28. Did I do that right? 14 minus 6 is 8, and 5 minus 3 is 2. Good, 28. So B is equal to square root of 28, but it doesn't really matter, which is officially 2 root 7. But you don't really care. All you care about was what B squared is, because they just said find an equation. All right, so I'm running out of room, but let me look at my thing. Where do I have room to write it so you can see? I think I still have a little bit of room here. The center is at the origin, so it's still going to be x squared over something plus y squared over something equal to 1. Since the major axis is going to, this is going to be an ellipse that goes sideways like this, horizontal, that means a squared gets to go under the x, so this will be 64. We figured out that b squared was 28, so that's what goes under the y. So that would be the equation there. The next one here is an ellipse, but the center is not at the origin. So you can tell the center of this ellipse is negative 1 and up 1, 2. So center is negative 1, 2. It looks like the distance between the center and the vertex is 1, 2, 3. So A is 3. The distance between the center and the endpoint of a minor axis is 2. So B is 2. So I'm going to write x plus 1 squared over something plus y minus 2 squared over something is equal to 1. Notice that the center is negative 1, 2, but I changed the sign. If they put them in parentheses like this, you always change the sign. It is horizontal, so I'm going to put a squared here, so this will be 9, and I'll put b squared here, and that's 4. So there's our equation of that ellipse.